that case, this is our second round of lightning talks, and we're going to have Ken Kahn here kicking us off. I will start to jump in when we start going maybe 30 seconds over, and for a 1 minute warning, I don't know, is it convenient for me to use like a reaction, like the shocked face? Anyway, I'll jump in if I have to. Otherwise, I will definitely post in the chat, and maybe post an emoji or a reaction at some point, or of some kind at maybe a 4 minute mark, so you know that we're getting close to the end. All right.
Oops, you're breaking up.
Without further ado, first we have if you can. Okay, so in that case, let's jump. We'll circle back around to Ken. Let's jump into Nathan Barry, the abstraction of. Oh wait,
Bernard says Ken is here now.
Ken is here. I heard Ken is here now.
Yep.
Is that right?
Yeah, I'm here now. Yeah.
All right. If you could take it away, the floor is yours.
Oh, I'm first?
Yep.
Ah, I saw a different schedule, but no problem. So Hugging Face is this company with a funny name and a funny logo, and their slogan is, you know, the AI community for the future. So so I discovered they had, when I did this a few months ago, 15,000 models in which they had public APIs in which you could talk to it, and now it's 20,000, and you could sign up for free without a credit card or anything, and you could get up to 30,000. So these are all text-based input characters every month, and if you pay $9 a month, you get 1 million or something. And the demo, this link is in the schedule, but it takes it a minute or two to load. So I'm going to stop sharing and reshare. All right, I got the right one. So now I have to. All right, so I assume everybody's seeing this now, right?
Yes.
Okay, good. So if I click on this first one, I'm running a model from that Facebook happened to have contributed that this particular one will, you give it labels. In this case, is it a refund, is an FAQ, or legal? And then the question or the sentence that it's judging is, hi, I recently bought a device from your company, but it's not working as advertised, and I'd like reimbursement. And if we look at the result, we see that the scores for refund is over 87%, for FAQ about 10%, and about 1% for legal. So it did a pretty good job on that one. And I meant to show you this first one, which is just translation. And here it's some group in Helsinki that have provided 1,300 different translation models. And if the model's already loaded, it'll just go right away. Otherwise, it gets loaded and it'll last like half an hour before it gets kicked off their servers or something. So this particular translation thing seems to be taking a while to load, but it's not loading into the browser, it's loading on their server. And if it doesn't work in a second, well, actually, while it's doing that, let me show you how this is working. So all it uses is the post block that's available from one of the libraries. And it's doing a lot of work to kind of put together the right strings for it. And then when the results come back, it treats it as JSON, and then it looks to see if it's an error. And if it's an error, it'll tell you that there was an error. And if it's if the message is that it's loading, which is what's happened just now, then it tells us about that and just tries again after a little bit of time. Otherwise, it just reports whatever the response is. And here's the response now. So if I blockify that, we could see, if people know French very well, that that's a decent translation. They probably don't remember what the original sentence was or something. So here's.
We are a few 15 seconds over.
Oh, already because of the. So the important thing is that there's so many of these models. There's ones for summarizing, for picking out the important named entities. It just goes on, and you could. And here's a little example of something that makes a little conversation back and forth and keeps track of the conversation and so on. And it's the one last thing I wanted to say, because I think at some point it'd be a good discussion, is API keys are really pretty awkward in Snap. And this was my solution, which is fairly long and lengthy, but it basically asks them if it's okay to store it in the computer if the computer's not being shared, and then everything gets easy. Otherwise, it keeps it as a transient variable so that nobody will accidentally share their key. So sorry about the technical difficulties, but I'll stop talking.
No worries. Well, thank you, Ken.
Sure.
Next we have Nathan Berry with the abstraction Obstruction. So if you could just start sharing and maybe confirm that you're here to start. There's one more little reminder. Maybe I'll use this celebrate reaction to let you know when we're at about 4 minutes or just over.
Okay, hi. Is it picking me up? Yep, cool.
Yep, I see you.
Now it's doing something. Okay, so I had a different speech lined up, but yesterday's flagship speech was pretty good. So I don't really have much of a speech up anymore. But the point I was going to make is, someone asked Jens after his keynote, what doesn't Snap do? And I know it's a feature of text-based languages, but one of the things I wish Snap had was a compiler. Basically, because as much as I love Snap, Snap is probably the programming languages I can get the most out of. I still think it doesn't go into enough level of detail. Maybe that's just the way I code. So it's 4 a.m. here and I'm struggling to stay awake. But yeah, no, basically it's a question of, do people think Snap is enough? Like, I love Snap, and like some of the projects that were released yesterday were, like the TuneScope thing is amazing. Snap with metaprogramming is pretty good. And Georgia's keynote about how she teaches high school students very advanced concepts for computer programming is impressive. I bought her book and I'm going to go through it myself. But I'm just wondering, could we do a compiler version of Snap is basically my point, because I think there's more that can be done as much as I love Snap. So yeah, that's basically my point, and I'm rambling now. So yeah, thank you for your time.
All right, well, thank you for your talk. Do you have, I think next we have teaching and learning model of creative collaborative or collaboration intelligence. If you are here, and you could start sharing your screen. I'm sorry, I'm not quite sure how to pronounce the name. All right.
If you're here, could you either comment in the chat or just start sharing your screen? In that case, we might continue rolling on. Okay, so next we have, I apologize for my pronunciation, but Taeryeong Kim, implementation of block programming for learning artificial intelligence principles. If you could share your screen and take it away. You have the floor.
Okay. Do you hear me?
I can.
Okay, thank you. Hello, nice to meet you, everyone. I'm not used to English, so I will speak slowly. You know, artificial intelligence seems to be a hot topic at this conference, right? So I do the same thing, but it's a real little differ about the mathematical understanding of artificial intelligence algorithms. As you know, the current paradigm of artificial intelligence is a machine learning and deep learning. And the most important in supervised learning is probably linear regression. As you know, I try to implement linear regression as a kind of training. So the basic implementation method of linear regression is to model the linear relationship between the dependent variable and the explanatory variable in the form of y equal mx plus b for a given data set. So at first, I tried to solve it with an orthodox calculation method using the slope and error of the derivative. So I implemented linear regression by moving a mathematical expression as it is. It looks a bit complicated because it is block programming, but it is a basic method using gradient descent, like this. Yeah. Okay. Unfortunately, that method didn't work. As you can see, the value grew up infinite and couldn't produce an exact value. And the same expression is implemented in Python. It seems to proceed without any problems. So it seems that the expression is not wrong. I'm guessing this probably involves floating point issues and space allocation issues. Of course, that's my opinion. If you have any other thoughts, feel free to tell me. If I execute this one, the value is go away. Yeah. So alternatively, a linear regression implementation was possible. This method does not use the differentiation through the learning rate, but corrects the value through iteration. But the reason I think it would have been good if the first attempt was successful. This is because the method is a cornerstone for mathematically finding other algorithms. If gradient descent using differentiation is possible, it would have been possible to implement logistic regression or other classification. Personally, I am very sorry, but I think that there is no way to do it due to the nature of the program running online. One idea I'm thinking of is to try to calculate numbers of 15 digits of offline. If you try complex calculations on your local computer through additional programs, I think you can give a little more room for numbers. I'm planning to try different ways in the future. If you have any ideas for this content, please feel free to ask. Yeah, thank you. Okay.
All right. Well, thank you for your presentation. I think this brings us up to. By the way, do you have any last minute things you'd like to say? Because you do have a little bit of time.
There are 2 questions in the chat.
Sure. Are you using the big library, and are you using this in class? Are you using...
No, I just using just no calculation, just calculation.
Well, are you using this in any class yet?
Sorry, could you tell me? Could you tell me the question to the text?
Yeah, so it is Jadga asked it in the chat. And this was just asked again by Mark Roman.
I will answer the question for the text. There is a lots of question. Yeah.
Yeah, sounds good. Feel free to go post your answers in the chat. All right, so then that brings us to Akos Ledeczi presenting variations on Wordle. Akos, the floor is yours.
You can hear me and you can see my screen?
Yep.
So I think probably everybody knows about Wordle and probably most of you played it. I try to play it every day. And when it came out, it took the internet by storm. So we decided to try to do something with it in NetsBlocks. For those of you who are not familiar with NetsBlocks, NetsBlocks is a Snap extension that kind of opens up the internet to Snap programs. Okay, so one of the things that we do in NetsBlocks, we call it services. That's basically a collection of functions that run on the server and provide something useful. We have lots of services. It is this call block that allows you to call these functions. We call them remote procedure calls or RPCs. And we have a large collection of these things like Google Maps, weather, climate change related, and so on and so forth. And so we decided to add a Wordle service. So you can find that under games, word guess. Okay. So, well, I should have picked it. Games, word guess. Okay, and now you can see what are the functions or RPCs that you have. The first one is get word list. Expects a length. So if I say 4, it will give me a collection of frequent words in English, like 820 of them. If I say 5, then it will give me over 2,000. And these are actually the same words that the official Wordle app uses. So what can we do with this? Well, we can start a new game. Okay. So this one will make the server pick one of those words. Okay, and now we can try to guess what that might be. So if I take a guess, it will give me, well, the first letter, 3 means green, 1 means gray, 2 means yellow, this is the right letter at the right spot. This is the right letter at the wrong spot, and the 2nd, 4th, and 5th are the wrong letters. So I can go on and try to guess what the word is, or if I am done, then I can give up, and it looks like the word was tally. Okay, so we have this service. So what can we do with this? If we switch to the right-hand window, we can actually build kind of a Wordle player, and here it is. No, actually, sorry, that's the wrong one. This is the one I wanted to show. So this is our Wordle player, and so now it wants me to take a guess. Again, I can start by guessing trace. In this case, that was a fairly unlucky guess. So let's pick something else. I don't know. It's no time to make intelligent guesses. I am not having much luck here. Let's see. Mouse. All right. Finally, at least I got a few letters, a couple of letters correct. Okay, and so you can see you can basically play Wordle. Unlike the regular Wordle, there is no fixed number of plays you can do. You can start the game over, and it's guessing a new word now. So we can again guess like this. All right. So that's just one way to make use of it. If I want to cheat, well, you can have a Wordle cheater. So let's say this. So here are the remaining words, all of the 5-letter words. So if I say rate that I guessed on the other side, okay, and now it's asking me, you can see the prompt, it's asking me for the score. So in this case, the score was 1, 2, 1, 1, 1. Okay, so now we only have 98 words left where there is a letter A, but not in the second place. And so I could continue and basically cheat in Wordle if I want to. Another thing that one can do is actually write an autoplayer. So now the program itself is playing Wordle with the server. And in this case, it was pretty good, but this is a really simple algorithm. It will pick an initial word that has a letter E, A, and S in it from the word list. Then it will guess that. Based on the feedback, it will apply the rules. All the information that we got in the previous guess. Now, this is not as straightforward as might you think. You have to make sure that first you apply the green rules, and you have to be careful about the order and some of the things. But basically, it will apply all the known information, and then from the remaining words, it will just pick randomly. So this is the simplest you can probably do. And if we play it a few more times, you see that sometimes it even needs 5 guesses. Sometimes it even loses. Now it needed 5. So students can spend their time to come up with better, more intelligent algorithms. And if you skip the whole user interface piece, you can actually just run this like 1,000 times quickly and gather statistics and come up with the best possible algorithm you can do. All right. So what else? Well, if the New York Times moves this behind the paywall and you don't want to pay for the New York Times, then you can use the daily word guess, which has slightly different options. Basically, the NetsBlock server will just pick 1 word per day, and you can then play Wordle just like you can now. And every day you get a new word. So for example, right now we have like 6 hours till we get a new word. So probably we are just using GMT and not your local time. And you can see that we have how many tries?
So we are a little bit over. But if you have any final comments, and then maybe we'll have to hop over to the next one.
Perfect timing. So basically you can see that we have 6 tries remaining, but that's all basically I wanted to tell you. So if you want to play with Wordle, you can just go on to NetsBlocks and play away. Thank you.
Awesome. Thank you, Akos. There were a couple comments in the chat if you want to share requests for links. So if you don't mind posting some of those in the chat, that would be awesome.
Sure thing.
Next, we have Jadga presenting about learning about vector graphics using Turtlestitch and Snap. All right, Jadga, the floor is yours.
Can you hear me?
I can.
Okay, great. So we're just fixing audio because we now needed to switch the thing. Let me share my screen. Dip, dip, dip. Dip, dip. So what I wanted to present today is a project that I haven't done some time ago, but last year I finished a few activity cards about it that I will translate to English soon. So I thought I might have it ready for today, but I didn't manage. So I'll send it to you in 2 weeks or so. So the idea is that we want to build a pixel drawing program, and kids or people can reuse stuff that they already know from programming games. So for example, here I made a mechanism where I can move my turtle around with the mouse key. Oh, oops, now I made a mistake. And the idea is that we now need to come up with an idea how we can remove the last step that we've done. So for example, we could store our drawing in a variable as a path. So I already made the variable and I also initialized it as a list already. So now let's try to come up with a solution how we can remove the last step. So for example, we could just, when we press a key, let's do R, for example, for remove, we could delete the last item of the drawing. But for that, we first need to log everything that we've done before. So let me clear everything again, and let's add a script that lets us log the directions we're facing to, and we can reconstruct the whole drawing from just the directions, because we're always going the same amount of steps for each time we click one of the arrow keys. So for that, for example, we could use the broadcast functions and just add a broadcast update, update after each of the scripts. And if we send that update, we want to react to it by adding our current direction to the drawings list that we have. So let me grab one of the add blocks, and we want to add our current direction to the list that I store in the drawings variable. So now when I move around again, I'm adding the directions that I'm facing at to my thing. So now I made the mistake again. We need to remove things. So we want to remove the last step, which we can easily do by just deleting the last item of the list. So let's delete the last item of the drawing again. But if I do that now, you see that the length of the list changes, but nothing in my drawing actually changes. So for that, we need to reset the whole stage after we deleted the last thing, and then we need to redraw everything that we have. And we can do that super easily by just using the for each item in our drawing, I added it to the wrong thing, sorry. Reset here. And for each item in our drawing, we now want to face into that direction and just move the number of steps that we defined up here. So move the number of steps and point into the direction of the item. Let's check that. So if I press R now, it deletes the last item, and I can go on drawing what I wanted to do. We can even make that faster by wrapping a warp block around it, so we can reset everything in one step. So if I delete the last thing now, I could go on like I wanted. The cool thing about this is that you can even extend the project by adding more options to also put the pen down or put the pen up, and then you can come up with different things that you can draw. So for example, this is like the Google dinosaur from the Chrome game, or you could come up with what else did I do? A space invader. And you can then also render it with different embroidery patterns. And as I mentioned, I made a few activity cards about that. So if you do speak German, you can use them right away. And they were made, so I made the content, but the graphics were made by a professional graphics designer. So it looks really great. And we have activity cards for kids that, or for students, that explain every step. And then I also made additional material for teachers that also explains how you can make your own blocks, what the shape of a block means, how you can create your own blocks, a few things about how Turtlestitch works. I even made a video about how to use the embroidery machine. So if you do speak German, you can try it out right away, and I'll post a link to the chat. If you do speak English, you have to wait for a few more days.
Learn German.
Or learn German, but I might be finished faster than you.
That's not clear.
Learning German. Okay.
Thank you,
That's my talk.
Jadga.
Thanks.
Thank you, Jadga. We're all right, and then this brings us back to our lightning talks. We have one remaining lightning talk called Genetic Programming Anyone. So Markus, if you would like to take it away, the floor is yours.
Yes, thank you. So hello everybody. Okay, so sorry for the delay. Can you see my screen?
Yep, I can see it.
Good. Now you should see something more useful than that. So welcome to Genetic Programming Anyone. It was called evolutionary programming, but actually the technical term for that is genetic programming. What is genetic programming? It's basically you create a bunch of programs, run them against the problem, and evaluate them against some fitness function. And those who are a bit better than the rest are propagated into the next generation, either by directly selecting them or by using crossover or mutation. So, here is an example of crossover. So basically, as we are a Lispy dialect, we also have kind of abstract syntax trees, and we could use that ourselves. I don't do that here on the blocks themselves, but basically I created a little kind of Lisp, parts of Lisp, where you store these expressions in lists, and I want to show you that. One more background of this genetic programming I want to give before I start with the presentation of the SNAP project is that even Mr. Alan Turing mentioned the word of evolution in the context of programming, as you can see here on the Wikipedia entry in the 1950 talk about or paper about machine learning and the Turing test or the imitation game. So genetic programming, anyone? Let's get started here by pressing the play button. So there's a nice paper from Mr. John Koza in the 1990s where he uses, I stopped that, I need to introduce that first, where he uses the, is it, yeah, no, down. Here it is. He uses the multiplexer example. Second, have it here. Come on. Here it is. So you have a multiplexer. So basically, you have here 3 inputs which decide on the output. So as you see, this is from binary from 0 to 7. You can select 8 different states. So if there's a 1, you get, or if this is all 0, you get the first one. If there's a 1, you get the second one, and so on. And so this logic serves as the example which he uses here as a training set. So basically, the domain of that is 2048 different entries in a table, which I can show you here. So there's a variable here which is called the truth table. No, the search space. So I've created that, and so basically, this is the fitness function is evaluating the evolved program against all these states, and computes zero distance if it gives the same result as the perfect multiplexer algorithm, and would give a distance of 1 if it's not giving the perfect result. So that is basically the fitness function for that. And to be honest, in this paper of 1990, he uses 4,000, generation of 4,000, and I think in the 8th or 9th iteration, he has evolved a perfect, perfect, how you call that, program, which solves this problem. But to be honest here, I'm too slow with this. I mean, it's kind of an old machine here, a 9-year-old Mac or 8-year-old Mac, but it's still slow here if I use that for computing this fitness function for the generation 1. As you can see, I have a generation here of only 20 guys, and so to be honest, I didn't even solve this one, or this example here of this multiplexer, but I've created the kind of framework to do that thing. I mean, it's a branch of machine learning. There are still conferences about that. I'm a bit distant. I'm not really involved in that kind of stuff. I was in the 1990s, and when Jens Munich talked about,
we are a bit over time. Do you mind sharing the link in the chat? so people can check out the project as well, and then saying
Yeah.
any last closing words.
Yeah, sure. So of course my presentation problems took away some time as well. Where is my chat, my Zoom thing? If I see my Zoom, I'm too stupid. Oh, here it is. Okay. Check. Oh, this is to anybody? No, this is direct message now to Brian. To all. Here we go. So this is the program. And yeah, what you can see here, just an example here of the list. So these are the expressions here, basically the lists of programs, and they get evaluated against the stuff. What I don't have is a block which would create real nice looking blocks out of that. And also, to be honest, the crossover has some issues right now, which I need to fix, but at least the framework is there. And I just, my call for action is if anybody's interested, please drop me a mail, and let's see if we can get that somehow further. So yeah, that's that.
Awesome. Well, thank you, Markus, and thanks to all of our presenters today. So if we could give them a round of applause. This wraps up our lightning talk session, and we'll be coming back at the top of the hour for our next set of talks. So thanks again, everybody, and we'll see you in the next session.